Hello? Okay, so there might be a little weird thing at the beginning there with me saying hello because my recording didn't seem like it was working at first. All right, so we actually just have, believe it or not, we really only have one function to write, even though it looks like we have three, because what we're going to do is we're actually going to write this last function first, and then we're going to use that to get these functions here. So I'm going to go into this function here. And the first thing I need to think about here is, well, I'm going to have to read in some data here. So I'm going to need some an unsigned int to store the data. I'm also going to need some int 16 to kind of store the bit shifted versions of it. So I'm going to say MPL 115A2 temp equals 0 and press. I might need some more things, but I'm not sure. Now this is where I do a lot of copying, pasting of my code as long as I do things right here. So I know I need to first, when I'm doing any kind of reading, I need to, yeah, no, I'm fine. I need to send some kind of start command here. Not start command, I need to send some kind of, hey, where are you pointing to? So I'm going to set the register that I want to point to. And it's in write mode, but what I want to choose here, I want to do, well, if I look at the data sheet here real quickly, that's not the data sheet. Going to the memory map, we want to do the most significant byte of the pressure first, because then we can just read all the things in without having to do any more pointers. So pressure, most significant byte, and then the send stop. One thing we did wrong here, and I forgot to mention it here on the previous one, so we need to fix it here. Technically, I think you'd be okay, but really what we should get in the habit of is on your last piece of data that you send a NAC, which is not acknowledged, which sounds weird. It is technically what it stands for, but basically what that's saying is, hey, you know, I'm kind of done reading data, get ready for me to stop reading data from you. And then you can see here I have the send stop at the bottom here, like we still had. Alright, so we've got that here, so we set the pointer. Now we need to read in pressure and temp data. And so we can, quite frankly, use some of the code here. So I'm going to do read the coefficients in, and I'm going to copy in the, whoops, I'm not reading coefficients. I'm going to copy in some of the stuff. Now it's giving me errors because I copied and the variable names aren't correct in this function, but we'll fix them. The one thing I want to put here is, maybe here, stop reading. And then I'm going to copy this in right away because you don't want to forget to issue a stop command. So I'm going to copy that in right away here. So stop reading. Oops. And I made a mistake here. I need to actually copy it into my function. There we go, stop reading. Now I need to, instead of reading A0, the first thing I'm going to be reading pressure data. So first off, this should be press, and this is going to be press, and this is going to be press, this is going to be press, and this is definitely not going to be there because that was we're going to have a different formula for computing the pressure, and it's in the data sheet here, which I'm probably going to copy and paste in a comment so that I can have it in front of me. This is why it's good to have it printed out. So we've got that, but we really need to again go to the data sheet to make sure we've read it incorrectly. Wait a minute here. The pressure data is 10 bits. See, it's 10 bits here. So we're having the same issue with it. So really what we have here is MPL115A2 is actually equal to pressure 9, pressure 8, pressure 7, 6, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, 6. This is what actually it's reading here. This is what's currently stored in. Maybe I'll say this here. Currently, MPL115A2 is equal to this. So we have the same issue we had with the C12 constant. Well, we know how to fix that already. That's an easy fix. So we just do MPL115A2 underscore press, and it's equal to MPL115A2 underscore press, and then we shift it to the right. In this case, we need to shift it to the right 6 spots, as opposed to 2, and then of course we semicolon that. So we've read in the pressure data. Well, temperature data is going to be exactly the same. I'm going to take that comment out there. Except everything now is temp. Now, as I said, with copying and pasting code, you can get yourself into a lot of trouble if you're not careful and making sure to change everything. Like, for instance, I need to put knack here, and because I'm done reading data, this needs to be temp, and then this needs to be temp, and this needs to be temp. Alright, because if you don't have it set up correctly, obviously you're going to have everything screwy. Okay, so then we're going to send a stop. Well, now the remaining thing here is, well, we need to compute both temperature and pressure. So I'm going to go, let me exit out of this. This is a stupid update for PSOC. It's not letting me actually copy that. Well, we'll just do this. Maybe. It's not worth the time. I'll just tab. So now first off, I should notice here, I'm going to need something called pcomp. And well, what is it going to need? Well, these are A0, B1, C12. Those are floats. These are not floats. They're integers. And in fact, I made one mistake here. These are unsigned integers because they have no sign bits here. So we need to go back here and rewrite these as unsigned ints. That's actually extremely important because otherwise it's going to look at the first byte and say, or not first byte, first bit, and say, that's going to be my sign bit on whether it's positive or negative. Alright, so that's important there that we fixed that. Okay, so what do we need here? So we need a pressure compensated, and we need that to be a float. Float pcomp. And I'll just initialize that to, I'll initialize that to -1. No, 0, because it doesn't read a 0 pressure. Duh. So we'll initialize it to 0. And the reason I'm initializing it to things is that way when I'm debugging, I can see, like, did anything change even? So because I know what it was initially. Alright. Then we have A0 plus, so I'm going to have pcomp is equal to A0 plus parenthesis B1 plus C12 times T. So this would be underscore MPL B1 plus underscore MPL C12 times my temperature data, so MPL 115A2 underscore temp. And this is why I think they probably do it in more than one line. And then so I'm right here now. So I multiplied that by the pressure. So times MPL 115A2 pressure. And then I add B2 times the temperature. Now that's not the actual pressure, that's the compensated pressure. See, it says it'll produce a 0 with an input pressure of 50 kilopascals and will produce a full scale value of 123 with an input pressure of 115 kilopascals. So that's where it's basically, this is just the slope it's computing here. You're just computing the slope of this line essentially, and then you're taking your and then this would be your quote x data, and then this is your y-intercept because you're going to start at 50 kilopascals. So that's my actual pressure then. So that's what I want to set star press equal to. I want to set that equal to pcomp times, and we can do the 115 minus 50, which is just 65.0 divided by 1023.0 plus 50.0, because remember we always want to put those point zeros when we're doing floating points. You might say, oh, it's going to be fine, but now notice here the pressure says, hey, it doesn't have any underline over that because we have it defined now. So the remaining thing we need to do is, of course, compute the temperature. Now the data sheet does have the temperature. It's not a nice formula, but it is buried in the temperature sheet. But I think there's an error in it, temperature computation. And so I basically just Googled here for some information on how to do the temperature conversion. And basically, if you really want to have an accurate temperature thing, you would really want to set up a test parameter and say, okay, I know it's precisely 25 degrees C, and so what is the ADC value? The ADC counts. Because really this ADC value, this is the, if we want to think about what this is that's what that is there. So at this point we can really just type this formula in, that the temperature is going to be equal to parenthesis MPL 115A2 underscore temp minus 472.0 divided by, I always like to put these negative numbers in parentheses for some reason, negative 5.35, and then plus 35. So that's what it says that the temperature should be. And this, of course, is giving it in Celsius. Now that could be other things you could do. You could create other functions, like where, now that we've kind of written the API, we could even create more functions now that we're kind of thinking about this, like, well, maybe we could put here, we could modify these, and I'm not saying we're going to, but I'm just saying, maybe we could modify functions to allow different units. So for instance, maybe you wanted the temperature to be able to return in Kelvin or in Fahrenheit, or for some reason Rankine, or pressure being in kilopascals or millimeters of mercury, so on and so on, you could add in additional, and these wouldn't be then void functions anymore. You'd have to give an input. It's like, okay, well, do I want it in Fahrenheit or Celsius, or you could just create separate functions. You could do read press F, read press C. There's lots of ways to do this. And that's kind of what you would decide as the person who created the API. But you would just have to make sure that you include everything in your data sheet. Now the whole point of this, and I know we're not quite done, is look at all the code we've written here. But now think about a user when they use our API. They're just going to have to use one of these 4 simple commands. And then all of this code that we've had to write here to get this to work is going to be automatically done. Now this one here, these 2 codes are going to be very simple. I'm just going to do float, and it's going to look a little weird here because I'm going to do float press, and then I'm also going to do a float on a temp, and then I'm going to just do MPL115A2 read press temp, and then I'm going to do can't get the right thing here. First off, what is it? Pressures first, so at pressure, at temp, and then, well, this is the pressure one, so I'm just going to return press. Now I know I'm not using temperature anywhere, but by writing this function that gets both of them, I don't have to rewrite all of that code then in here. I can just say, okay, well, get both of them. I don't need both of them, but get both of them and then just return pressure. And there is one vital command we missed here. And this is going to be temp. So this is all correct here. Maybe some of you have caught this. There is one thing I have to do here first. I can't believe I forgot to do this. This is like the most important thing to do. Start conversion. I have to actually make it make a conversion. Now, this is where I also want to go back to the data sheet. This is where if I had the data sheet printed out, I probably would not have made these mistakes. Did I just close out the data sheet? No, I didn't. I was looking up. Okay. Okay, the conversion completes with a maximum conversion time. See row 7 in table 10. And conversion time, it can take 1.6 milliseconds up to 3 milliseconds for it to do that conversion. So believe it or not, we're going to put in a delay here. And remember, this is just 3 milliseconds. This is the maximum time to perform conversion. And I want to put that there just because I don't want the processor, no matter what one I'm working on, to be working so fast that I could start reading data in before the conversion has been performed. So this way it guarantees me that I'm going to have the data converted. In 3 milliseconds, I mean, that's not going to be noticeable to the user. Alright, so now we're done with our code here. So we have our API. So now we're ready to debug and test it.